Topic 5-1, solving equations by factoring. On this equation, at quadratic equations, so that's why I put a calculator here, because a lot of these you can actually put into calculators. But in the very first part of this, we're just trying to explain what solutions, when they say the word solving, this can be found in our Holt textbook, Chapter 9, Section 6 on page 630. You can actually look at those pages and find out some practical applications to this, and that would be things like throwing a ball up in the air and seeing how long it takes to get back to the ground. I think the one in the textbook is of a diver who is diving off of a high dive and how many seconds it's going to take to get to the ground. So you're looking at quadratics on all of this unit. And so you can think about a quadratic as either going in the direction that it has a maximum. So this would be your max. I'm getting a little bit ahead of what you're going to be looking at later. Oops. Or it could actually be going this direction, and it would have at its lowest point a minimum. So these would be positive quadratics. These have a negative x squared. But you're always, when you're solving quadratics, you know you're looking at problems that have this in the equation, x squared. Now these four problems have already been broken to their factored form. So you got to remember that if a times b is equal to 0, what must be true of a or b? Well, if you're thinking about this right here, this would have to be a 0. Whatever you multiply by would have to get to 0. Same thing with here. Whatever number is there, you would multiply it by 0 to get 0. So in quadratics, a big common mistake is students don't put them set equal to 0. This particular page, all of them have equal to 0. So what you're doing is you're breaking up the factor. X you're going to set equal to 0, this x here, and then x minus 2 equal to 0. If you're solving for x, we have to add 2 to both sides. Therefore, this goes away. So one of your solutions is x positive 2. Later on, you're going to be graphing this, but if you want to kind of visualize what that might look like in a graph, if you were to put this equation exactly like you see it into your calculator, this is going to hit right at 0, 0, come down, have a vertex point, come back up, and this would be at positive 2. This point would be at 0, 0, and put that in a coordinate point. This is actually at 2, 0. Your y's will always be zeros, which later we'll discuss how to look for those in the table in your calculator. You don't have to actually show it by graphing now, but I'm just kind of giving you a little bit of head start. So let's try this one since I have a calculator here. If you put x, parentheses, x minus 2, close your parentheses, and then just graph it, you're going to see that it crosses at 0 and also at 2. And when I was mentioning the table, to get to the table you hit second graph. You're looking for where your zeros hit. Since I know it's 2, I'm going to go back up here, scroll back up. Where you walked over 2 and didn't go anywhere, and 0, 0, it started at the origin. 0, 0 is called the origin. So let's do a couple more without the calculator. You're setting both of these binomials set equal to 0. So x minus 3 is equal to 0, and x plus 4 is equal to 0. Add 3 to both sides so that x would be 3. This you're subtracting 4 from both sides. So this would be a that goes away. This would be a negative 4. Can even show it. 3 and 3 to both sides. 3. So one of your solutions is 3. The other solution is a negative 4. Go over here and box these solutions. Okay, this one's going to end up with a fraction. You've got 2n minus 4 is equal to 0, and 3n plus 5 is equal to 0. See if I can focus this a little better. I guess that's as focused as it's going to get. You're solving for n, but first you move the constant. You're moving a 4. That would cancel out. 2n would be equal to 4, so n would be equal to 2 when you divide 2 on both sides. Subtract 5 from both sides. 3n would be equal to negative 5. Sorry about that. Negative 5. And when you divide by 3, you're going to get negative 5/3. Leave it as a fraction instead of a decimal. So this is one of your answers for this one, and this is your other answer. Okay, this one's already in a quadratic form, so you would want to factor it first. Or this one, since it's not in its binomial factored form, we can do what we just did with the calculator. And your y equals, bring that back in. Try to get it where it can see it better. I'll put it right there. Alright, so you're going to put in 2x squared minus x minus 28. And make sure you use a minus sign and not this sign here. That's a negative sign. Yes, if I read that by itself, it would be considered a negative 1x. This would be considered a negative 28. But if you're saying it in a problem, you say minus 1x minus 28, you're using this button. So sometimes students end up pushing this one. Be careful, you won't get the right thing. So I'm going to graph it. Let's just look at where it goes. It appears to be on the 0 here, but not here. So if you go to your second table and you're looking for a 0, one of your zeros is 4. X equals 4 for one of them. But the other one was a negative number, and if you notice, it's actually between, let's see, it goes down, starts to come back up. But you know the number is going to be between a negative 3 and a negative 4. It'll cross the 0 again. This one, however, doesn't show you on your graph exactly where that is. You can, if you were testing, just use your arrow button and arrow over until this little plus sign kind of hits the line for an estimated guess at about negative 3.4. So we want to be more exact. So here's the steps to do that. Watch closely and rewind the tape if you need to look at this again. But you want to first go back to y equals. Put in a 0 for your y2. By putting in a 0, you now can calculate the intersection, I'll kind of draw a picture of it, of where y equals 0. Well, if you think about an intersection of your this point right here being y equals 0 is the x-axis. And then this is the parabola that I've put in a quadratic equation. So if you'll do this, make this in there, then you can hit second trace, which gets you to the calculate, and calculate the intersection. Now with the trick on this, it's already flashing on this side, so you're only going to use these arrows and move the cursor close. You're moving it close to the other side. And remember, it was around 3 something. So watch this X to where it gets about negative 3, and it was getting close. So we can get as close as we want, but we're getting a more accurate 0 by hitting enter, enter, enter. You might have done this with linear lines using that intersection button. So your other X is equal to a negative 3.5. Exactly. It'll hit the Y at 0 exactly at 3.5. So we wanted to be more exact, so we used that steps. If you need to go over that again, see your teacher and they can show you this in one of the TI-83s or TI-84. Or actually even the new Inspires, we can use these. I just didn't bring that one home. Okay, we're going to do the second half. Try not to get it to flash. Let's see. Okay, number 5. Notice how each one of these are not set equal to 0. If we set these equal to 0, we can actually use the calculator again. I'm going to clear my calculator for the y equals put it over here. I'm going to clear the calculator for y1, but I would leave the 0 in case we need to do the intersection trick again too. The key here is everything has to be equal to 0. We don't necessarily want to make our quadratic negative, so let's keep it positive and move everything to the left. If I subtract 24, then I'll get a squared minus 24 on this side. And then let's just do this in steps, and negative 5a. But I'm still trying to get to 0, so we've moved this one over. Now let's move this one over by adding a 5a. So if you add a 5a to this side, this one goes away. So notice how all I did was I moved this over there and this one over there. So that became a squared, we'll put it in descending power order, 5a minus 24. So now everything is set equal to 0, and you can use your calculator. So let's put this one in. A can be x. You're always going to use this universal button x for this. And this could be squared. You can use the house top squared if you're used to doing that. Plus 5x minus 24. And I have a 0 there. Let's just graph it, see if it looks as if it crosses both lines. Notice how it went here, and then it's possibly coming up way out that side. My calculator has been zoomed in, so if you want to, actually probably zoomed out. So if you want to zoom and get it back to its standard form, hit the zoom button and go to standard, and it'll put it back where you can see both of them. So it appears to be at 3, and it also looks as if it goes exactly on 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 and 3. Let's check that. Go to the table and then look for zeros. One of them was at a positive 3. And remember the other one was at negative 8. So we need to go way down there. And negative 8. So you found your zeros in your y. Don't look for zeros in your x when you're using the calculator. You've walked over a value of x. You want to see the picture again. You've walked over a value of x. 8 over here is a negative 8 with a 0 in your y. You walked over 2. Is it 2? I think it was 2. I don't remember. So not that 0. You're not looking at that one. You're looking, no, it wasn't 2. It was 3. 3, positive 3, 0. So your two answers for this problem, you can actually put them in brackets. Sometimes you'll see test questions answered this way. The brackets don't mean the coordinate point. It means your two x's, and they'll separate it by a comma. So it looks kind of like a coordinate point, but it's not. It's the solution where it crosses the x-axis on your coordinate plane. Okay, this one needs to be also set equal to 0. So by moving this 3, remember I said we would try to want to make these positive when we can. So if we can make that positive, let's do so. If you add 3 to both sides, 3x squared, you now will have 3x squared. You can leave it like this, minus 6 minus 19x. I just usually like to put my power in my variables in descending order. But now we have this set equal to 0. So let's look at this one in the calculator. Y equals, clear that one out, 3x squared minus 6 minus 19x. Now this one you probably will have to have a 0 and find intersections. The key note is if there's a variable in front of your x squared, more likely, well, always, you're going to have one at least be a fraction. One of your binomials will have a fraction. So second, well, let's look at the graph. It's pretty tight right there. Pretty tight right there. So it looks like it might, well, they both are, I think they're going to be both be fractions. So let's just find out. Second, calculate, find the intersection. The cursor's already on this side, so we'll just get that one first. First curve, second curve, guess. You hit the intersection 3 times. This one doesn't appear to be an even fraction, but here's how you find out the fraction. You may have used the math button. You first clear it, and then hit math, and then hit enter twice. So it didn't do it, so let's just leave it in that form. Negative 0.3, carry it out maybe 3 places. So that's one of your x's. So for the next one, we'll hit second calc again, intersect. This time we'll find the same one if you leave the cursor over here. Don't push the up-down movement, or you'll find your cursor off of the parabola. You move it using the left and right. So it looks like it's around about 7. So we can kind of look at my x adding up to about at least 7. So there it is, 6.8. It's pretty close. Enter, enter, enter. So your other x is 6.63. So those are your two x's. Could be written like this or can be written like that. Okay, last one. This is an application problem. If you've got let's get rid of this. Quick. The area of a rectangular room is given in this equation. Where W is the width of the room, find the width. So you've got it as equal to 18. So you want to set it equal to 0, minus 7W, minus 18 equal to 0. Because 18 is positive over here, so you're going to subtract 18 on both sides to where that would go to 0. Now that it's set equal to 0, we can put it in our calculator. Here we go. Just be able to see it. So we're always using x squared minus 7w, 7x, minus 18. Graph. That one looks like it's exactly on a line, so let's just check the graph first. See, negative 2 is one of your zeros. It's kind of way out there, around 8 or 9. Look at it, it's 9. So you have your answer to your solution as negative 2 and 9. So your w's are equal to negative 2 and w is equal to 9. Now be careful here. If w is the width of the room and they want to find the width of the room, think about your answers. Can we have a negative length? This could not be a length. Not a length of something. Why? Because it's a negative number. So we're not going to use this one. So 9 is my w. So 9, is it given in feet? Doesn't say. Given in this equation where w is the width of the room. So it's just saying w. So w is 9. So 9 units. No, just 9 units. Squared is if we found the area. They've already given you the area. And that concludes 5-1.